Hello everyone. In this lesson, we will be learning how to insert math equations and symbols using Latex in Jupyter Notebook. We will talk about the general rule, Greek letters, accent sign, big symbols, relation symbols, subscript and superscript, fraction, binomial and stack number, matrices and array, radical sum, limit, integral. We're also talking about equation formation and numbering equations. Latex or Latex is a typesetting language for generating scientific documents. In this lesson, we only touch a small part of the Latex mathematical notations which can work in Jupyter Notebook. Okay, let's come to the general rule. We can add math equations and symbols by using Latex syntax, starting with backslash, begin, curly braces, equation, like this, and ending with backslash and curly bracket equation. Yeah, this one. For example, we want to insert an integral calculus formula as this one. We start begin equation, this one, and then backslash frac means fraction, dx slash this backslash sin x equal slash cosine x, then the end equation. We can got this output. You don't worry about the fraction, fract, something we will talk about later. And we can also use $sign, $2 signs, instead of beginning equation and end equation. And this is much more simpler. We usually use this way. For example, the above integral formula, we just put $, at the beginning and the end. It renders inline as similar. We can also include Latex codes in double $sign. We use a double sign, $sign at the beginning and end of the equation in order to centralize the expressions. You see, if we put double sign, $sign, the output like this in the middle. Okay, let's come to the Greek letters. Greek letters are widely used mathematical symbols which comprise of backslash, also backslash, and the name of a letter. Let's come to see the lowercase Greek first. We can create a lowercase Greek letter if the first letter of the name is lowercase. We see some examples here in the form. Dollar, backslash, alpha, dollar here. The first letter, the whole letter are lowercase. Beta, lowercase letter, and chi, delta, and so on and so forth. I will put all these lesson note online. You can download it for your reference. We need it's unnecessary and waste of time to read all this one by one. As you know, there are also some various Greek letters. Or we call the alternative, which can be created by adding var, vary, var before the name of the letter. For example, this one, is the variation version of epsilon. We just put backslash var epsilon. The outcome is this. Also another var kappa, var phi. This. Okay, let's come to the uppercase Greek. We can get uppercase letter if the first letter is uppercase in Jupyter Notebook, but there are some exceptions like alpha, the beta, and mu or mu, and nabla. We just use $A, $B for the alpha, beta. Means the uppercase. Like just now we mentioned, mu, mu or mo, this one. And also nabla, this one. They are all lowercase. You see, lowercase. Here, this one. Okay, let's see the accent sign. In the accent signs, we usually put an accent above it, like this, this. We write, use a backslash, acute A, this one, bar A, put a bar, or brave A, dot A. Besides, we also have overline, like this. Overline ABC is a long line above ABC or D. No matter you put how many letters. We use wide head. There's a head. Head A. But if there's more letters, we use wide head, like this. Wide head A, X, Y, Z. Wide tilde. Is a tilde, wide tilde. Another things we should pay attention to is if we use like this, head I. You see there's a dot I. But if we don't want to this dot on I and G, we use head in math slash in math. Then you see there's no dot on I and also G. These two letters. Let's come to see the big symbols. Big symbols we use big at the beginning, like slash big cap. This is a big cap, or slash big cup. Big SQ cup, square cup. Other things, let's see the integral. If we write a slash integral, it's single. This integral symbol. We can write I integral, in this way. this double sign. If we put II enter, then 3, and so on. We also use this means multiple integral signs. We use I dots enter. Yeah, this way. Also, another is the closed contour integral. We use \O enter this way. Yeah, and so on. Well, let's see the relation symbols. Relation symbols like this one, approximation. We just use the \approx, and because /because, and for the greater and or equal sign, greater than or equal, there are 3 ways and 3 symbols. If you like it, use this. We use G/G E Q equal G E Q. If you want to use this symbol, you use GEQQ. Or this one is GEQ slant. Also this less than or equal, yeah, the same. We use L, means less. Yeah, the similar things as this greater than or equal to. Another things we should be aware is this one. Is we use \not /subset. Not this one. Not this. You see, it's usually we use n subset equal n subset equal like this. This is super, this is super n, but for this one is /not /subset for this symbol, this one. Yeah, you can learn this carefully when you use it. Also, this one is plus. This is means price and minimum minimize. Sorry, minimize price, minimize, and minimize price. This one and this one. Okay, let's see the subscript and superscript. Or subscript and superscript are widely used in mathematics equation, but it's also very easy. We can create the subscript using underscore, this one, and create superscript using caret symbols. Let's see this one, y I xi cubic plus b. We just type y underscore I equal x underscore I, then this caret 3. Yeah, that's easy. Okay, let's see the fraction, binomial, nominal, and stack number. First, come to the fraction. A fraction can be created with \frac is 2 pair curly bracket. The first curly bracket is for the numerator, and the second is for the denominator. for example, this one. Yeah, A, B's. We write backslash frag A and B. Yeah, these two pair curly bracket. Fractions also can be arbitrarily nested. For this one, you see the numerator is nested. X minimize 1 x is a fraction. Yeah, two fractions. We write, for example, this one fraction, this big one, and this is just as I said, x minimize 1th is the numerator. Yeah, the numerator. Then we write the numerator in this way: x minimize another fraction. Yeah, a backslash fract. The numerator is 1. The denominator is x. Then the b denominator. Yeah, it's easy. But the special care needs to be taken to put the brackets around the fraction. If you want to put this round bracket like this, if you write in this way, these parentheses, the right also parentheses, you see the result is this. But the brackets are too small, or very small. The solution is to precede the bracket with backslash left and end with backslash right, the parentheses like this. Left this bracket, round bracket, then the equation, then backslash right, another bracket. You see, it produces a large round brackets. For the Latex, there's 3 ways to generate these fractions, like a backslash frag and backslash d frag and a backslash t frag. The difference between them is the backslash frag means that the actual context implies the decision above, and the d frag means the fraction is in display style, which creates a larger fraction. T fraction means the fraction is set in text style, in fact, which creates a smaller fraction as the backslash frag. Let's see the example. We create a frag AB, D frag AB, and T frag AB. You see, this is the result. Yeah, the D frag is bigger, larger. Okay. But if we use display style for the frag, like this, for example, D frag AB, and display style, we put backslash display style, then the frag 1, 2. You see, they produce these results. They are the same. Okay, let's see the binomial. Binomial also we produce by a backslash binom, two pairs of curved brackets. For example, we want to produce this. We use backslash binom n and k, n k. Yeah, then this fraction. Binomial coefficient can also be fraction. Yeah, like this. Yeah, we use 1/3 or minimize 2/3. Yeah, produce this one. Let's see the stack numbers. Stack numbers, in fact, is a special fraction, or it looks like the binomial. Nominal. Yeah, is this one. A, B, without a parentheses, is E, like EF. We can use backslash gen, gen, generate. That means general. Here is a general fraction. Means we use 1, 2, 3, 4, 5, 6 curly bracket. The first here, the pair, the bracket is left delimiter, maybe empty. Yeah, that means there's no left delimiter. The number 2 is right delimiter. Number 3 here, this one, is the fraction bar thickness. Yeah, is the thickness set to 0 point to make it disappear. Yeah, if we put 0, that means no, it's invisible. In fact, disappeared. Number 4, for 4 we can use number 0, 1, 2, or 3, where the 0 denotes display style. Just now we mentioned the display style is big, makes the means the equation big. 1 denotes text style. 2 denote the script style. 3 denotes script style. This number 5 is in the new numerator. Number 6 is the denominator. Let's see example like this. We write EF. You see there's no delimiter. Yeah, these two are empty. We use 0. That means display. Yes, not this here. This fraction bar thickness. We set 0. That's no. That means no. Yeah. Also, we leave this. The first, second is empty. This is empty. This 3 we set 0. Number 4 we set empty. Nothing. Yeah, that means normal. And also we put E. Yeah, this numerator is E and denominator is F. See, it's like this. But for this one, you see, we Jenny, Jenna, or Jane, frag. Yeah, is the left parenthesis, right, left, right. Then 0, we put another 0. That means display style, so it's big than the first one. Then we A, the numerator, B, denominator. Yeah, it looks like this. Let's see the matrix and array. In fact, it's a very convenient way for these above methods. Let's see the matrix. Matrix, we can use unbracket matrix. There's no any bracket. We can use P bracket matrix. That means the matrix surrounded by parentheses, the round bracket. B matrix surrounded by the square bracket. Yeah, this one, square bracket. V matrix surrounded by the single vertical line or the pop. Big capitalized V matrix surrounded by the double vertical lines. Yeah, this way. Yeah, let's see. Yeah, the plain, there's nothing, no any bracket. We write a begin matrix. We are just write a matrix. Then A, B, C. There's an and. That means space. So another here is double slash, means change the line. Yeah, change the line. X, Y, Z. Then end matrix. Yeah, we can use here use the dollar sign or without dollar sign. This one, because it beginning matrix, end matrix, the begin and the end. Yeah, we can omit the dollar sign. It's like this. Just to know, we said begin P matrix, P, end P matrix, like this, and so on. To create a matrix with different delimiters by adding them manually to a plain matrix. Like this, for example, the ceiling bricks, we can use the backslash left, backslash L means left, seal, yes, means the seal, yes. We produce ceiling brackets. Also, and matrix right, yeah, R, seal means right. This means right, yeah, left. Yeah, produce this. We can also produce an angle bracket like this. Left, here's left angle. Then begin the matrix. Yeah, this is the matrix. Then end matrix. Yeah, right means R angle, right angle. R means right. Yeah, we can even produce a mixed. Yeah, mixed term like this. We can also produce matrix with different types of dots. These are also widely used in mathematics. You see, like this. There's dot. That means there are many rows and columns. Let's see. There are 3 type lines. In fact, 4. But this one means this H dots for N doesn't work in Jupyter Notebook. So here we don't talk about this. We are talking about the other 3. Line is line dots, means line dots. Diagonal means DD dots, diagonal. Yes, this one, diagonal. And vertical, yeah, V dots, this vertical. Let's see these 2 matrix. Begin, we can use $, or omit because begin. Begin B matrix, we use bracket, means square bracket B. X underscore means subscript, we just talking about above. and yeah, x underscore 12, x underscore 13. We use here is dots slash dots and x underscore 1n. Yeah, this dot, the first line. Yeah, this line. Then we create the second line, third line, the last line, the C. But let's see this line. There's a line dots. Yeah, there are 1, 2, 3, 4, 5 line dots. We use backslash L dots and L dots. Yeah, just use this L dots. It produce this line. Here is the third rule. Okay, let's see the right matrix. We use begin B matrix. Yeah, the same. But here you see we use here we use the V dots, vertical. Yeah, V dots, V dots, V dots. But this one we use diagonal dots is D dots, backslash D dots. Yeah, we produce this. But here, oh sorry, I forgot. Here we have to use $1 sign or double dollar sign, because here's a equal symbol. If, for example, if we let's see, if we move this dollar sign, you can see is a mistake. Yeah, there's a, so because there's another symbols like equal, so we have to write this dollar sign, double dollar signs, to make it central alignment. See? Okay, let's see the inline matrix. Sometimes you see we are write like this. Let's insert an inline matrix here. This is the text. We want to write a matrix. Yeah, like this. We can write this. Let's insert an inline matrix here. For example, use dollar, then begin P matrix, for example, end P matrix. And you see, if we adjust this part, if we write the, you see, it's very big. This one is big. How about we produce small like this? Yeah, we just write in this way. Looks big. Let's make smaller by using big. Yeah, we write slash big, the parentheses, then the code. You see, this one. Then end. The begin here we write smaller matrix. We write smaller instead of P matrix. But here we use a big. Then here we write small matrix. Then end also small matrix slash big. Then the another round bracket. So it looks like this. Yeah, it's smaller. But we can also use in backslash big L and backslash big R means big left, big right. Let's see this example. We use begin, right. For example, we write the B matrix, begin B matrix, end B matrix. This one is big, but we write this way: slash big left, this bracket, and then here we also still use small matrix and small matrix, backslash big right, this bracket. Yeah, this way. But here, the above here, if we just use smaller matrix, is for this round bracket, not for this square bracket. So in this way, we can use any kind of bracket. Okay, let's see the array. Matrix and other arrays. In fact, matrix is a special array. Can be produced in Latex using backslash test, the BF array environment, or we just call this array environment. For example, let's produce a three matrix. Yeah, this way. ABC. Yeah, 3 multiply 3 matrix. We write this code, backslash left, this parenthesis, then begin array. Yeah, here we use begin array. Here's the CCC. That means center. Yeah, all the we can see the 3 rules, the elements in the matrix or array are centralized. If you use L, that means left alignment, yeah, or right means right alignment. We write this. This is the elements. Yeah, this into this here. Then we end. Yeah, backslash end array, backslash right, then another parenthesis. Okay, yeah, it's easy. To produce a table-like matrix or array, we can do this. We wanted to produce this one. Yeah, here, for example, item, variable, operations, outputs. First variable x is 2. Second variable y is 4. Sum x plus y is 6, and so on. We produce this. Yeah, let's see the syntax. We begin array LCC. That means the first rule, all these rules are left alignment. C, the second, third are centralized. Here we use M box item. Yeah, items. Yeah, M books, and another M books, which contains the variable operation, and another M books outputs. Then we change the line. Yeah, here we also use M books. Yeah, 5 first variable and x and 2. You see. Then the next line, until to end the array. Okay, it's very good. Sometimes we also write in multi-line formula like this. It's also very easy to use in the array environment like this. We are just absolutely x. We use left we use this curly bracket, this one. Here's, you see, we use another backslash, then the curly bracket. That means this is a symbol. Yeah, not like this bracket to contain the array. Yeah, here that means skip. You skip this one. Yeah, that's easy to understand. Then we begin array. We use LL, means left. Yeah. Then the first here, this line, first rule, X, and we use mbox. Then we write if X GEQ. Yeah, that means more than or greater than or equal to. Yeah, we use GEQ. If you forget, you can go to the about table to see this. Yeah, these symbols. Then the last line, this one, is here. There's a mistake. It's okay. I think I could change. Here's one. This we can write multiply 1. But this is correct. Yeah, this is the correct code. This is just for your reference. If we put all these in a cell, if we write, we got this. Just for your convenience to read this note. Okay, let's see the radical. Radical can be produced with a backslash squared. Yes, squared, 1 squared, then bracket. Yeah, this. For example, let's write squared, x plus a, this. But here, why there's no this square? The just the curly, no square bracket, this one, because for the base 2, it can be omitted. Yeah, here's the base 2. The bases other than 2, we write this. For example, this 3, squared 3, then x plus a. Yeah, produce this. It's not so hard. Let's see the sums, limit, and integral. Yeah, typically, you see the notation is sum. This is underscore. Yeah. Then I0, the caret in infinity, x underscore I. Yeah, we produce this. Yeah, here's I this one symbol infinity. Also this one inter underscore a caret b. Yeah, this is underscore a caret b. Yeah, the above. This limitation, we use lim underscore. We write this part x, then is backslash 2. this arrow, then A, then the fraction. Yeah, we already familiar this. Limits this specified by if we write in this way, sum limits underscore I0 carets in this way, it produce like this. What's the difference? You see here we use sum limits. We just put this one becomes, here is I is on the right, but this one on the bottom, below, this is above. We write in this way, sum limits underscore I carets infinity x underscore I in this way. But this one is here. We produce this here, just add these limits. We also write this in inter limits underscore e carets b. You see it is shift to the bottom and above. Similarly, this one we put limits underscore put this x to a under the limit. Okay, let's see the display style here again. You see this one, all these and these look smaller, especially you see here or here is smaller. But if we use display style, we put display at the beginning of this syntax. Just slash display style slash display style. You see it produces a bigger equations or the expressions. Okay, let's see the formation. The equation formation, the first important thing is resizing the font size. We can use this way, slash tiny. We put slash tiny, then the expressions is very small. We can use the bigger, the capitalized. The first letter is uppercase T. It's a little bit bigger. If we use script size, put script size. It's a little bit larger than the about 1. If we use a small like this, it's larger a little bit. Then normal becomes larger. This normal, put nothing. Or we can use normal size. Normal size and put nothing. This normal. It seems this normal size is a little bit bigger than this. Put nothing. Or we can use a large. We can capitalize the first letter. It's large. We can make it even larger to capitalize all the letters. It's larger. And huge. The look is huge. Becomes larger than the large. We can capitalize the first letter H is very big, huge. In fact, for the Latex, there's also a footnote size, but it doesn't work in Jupyter Notebook. But those, yeah, I think size are quite enough for us. Also, we can use different math modes, like normal. We like normal equation or expression. Display style we already mentioned. Also, this is script style, script style, and a test style. Yeah, this style form like this. This is normal. This display a little bit than normal. Script style smaller. Script style even yeah, smaller than the text tile. Text style is similar with the normal one. Okay, let's see how to change the fonts. Yeah, we just use like this. Default means you just write nothing. If we put math RM, that means lumen. We put math BF, bold lumen. We see the code maybe here. We just put slash math RM, or we put MTBF. This is bold lumen, like this. Yeah, you can change the fonts as you like. Okay, let's see how to change the color. Change the color, we just put this / color, for example red, then curly bracket contains the expression, symbols or equations. Here. For example here becomes red. This is blue. Just use / color, then curly bracket contains the color name or RGB or the color code. Then another curly bracket contains the expressions. I use expressions means maybe it's a symbol, just one letter, or is a math equation. It looks like this. Also, another way we use HTML. It's very convenient. For example, here we write a paragraph P. We use P, not paragraph, but this equation as a paragraph. P style text line. We make the center. Make it the center. Font family, Times New Roman. Font size 2.0 EM. Color red. Then dollar. The equation or symbols. Not a dollar. Then closing this P. So the outcome this. The last topic is a numeric equation. When we write something, we usually put a number here. We can put a number 1 or even chapter, subchapter number like this. 11, for example, 11 1. How did we do that? Here. Maybe I should write a code here. We just see the code. We used this X. This is the equation. Here we use a / tag. Then we use here 11.1 in a curly bracket. Then we use a label. Label is equal. Then this colon special. because if we want to reference this equation, we write this. If we write it like this, you see here, yeah, it can be referred to equation. Yeah, we just use backslash equation means EQ reference. Yeah, this part. Yeah, it automatically reference to this. It's like a ID. Okay, it's a long lesson. Thank you for your attention. Thank you.